Okay, if you like this video, um you can share it to your friends, and if you haven't subscribed to my channel, I would like you to do so by subscribing to my channel. So this is number 2 example, and this is the diagram, the problem we are about to solve. So step 1 of it, we have sum of forces at x, which is the left hand equals to the right hand, and here we don't have any x direction force here, so we leave it blank like that. And we go to sum of force in y equals 0. Upward force equals the downward forces, so we can also call it clockwise equals anti-clockwise direction forces. So let's say okay, our sum of force in y, there we have the reaction at A and also the reaction at B. They are the both forces facing upward, so we have we are going to sum them up, which is the RA multiplied by we are going to sum them up, which is the RA plus RB is equals to we have these 3 forces here pressing the beam downwards. We have the 2 kilonewton, 4 kilonewton and 2 kilonewton, and these are them here pulling it downwards. So we are having the 2 kilonewton plus 4 kilonewton plus 2 kilonewton. So by the time you sum them up, we are going to have total of 8 kilonewton, and you make it with your equation 1. Now the step 2, we are going to find your step 2, find your reaction by taking moments either from reaction A or B. So moment is what? Force times distance. Now at reaction A, let me first of all get the diagram and bring it on the screen. Okay, so this is the duplicate of the diagram. So I'm going to work with the duplicate now that is on the screen. So we have our RA here, and we want to take our moment at RA to get our reactions. Now when taking moment at RA, our RA now is going to be RA multiplied by 0, because we are taking moment at RA, so the distance is going to be 0. So then plus RB, these are RB, then the distance from RB to where we are taking the moment RA, so it's going to be 1, 2, 3 and 4. So it's going to be RB multiplied by 4, then equals to, we have what, 2 kilonewton at point C. Then the distance from C to 1 RA is what 1 meter, so we have what 2 multiplied by 1, then plus we have 4 kilonewton. 4 kilonewton, the distance from 4 kilonewton to RA is what 1 2, so we have what 4 multiplied by 2, then plus the distance from point E, RA is what 1 2 3, so it's going to be 2 multiplied by 3. So therefore our RA multiplied by 0 is out, so we have RB multiplied by 4, which is this one. RB multiplied by 4 equals what 2 times 1 is 2, then 4 times 2 is what 8, then 2 times 3 is what 6, then our RB times 4 is going to bring it, our RB times 4 is brought down again, and then 2 plus 8 plus 6 is going to give us total what 16. Then we are going to do what, multiply both sides by 1 over 4. While multiplying both sides by 1 over 4, we are going to have RB multiplied by 4 is this 4 here, then times 1 over 4, then equals to 16 multiplied by 1 over 4. We are trying to make RB subject of formula, so RB now, this 4 here will not cancel this 4 here, then will not be it, then we'll now have what RB equals, then this 4 here, 4 into 4 is 1, then 4 into 16 is 4, so we'll have RB equals what 4 kilonewton. Then at equation 1, remember our equation 1, we say RA plus RB is equals what 8 kilonewton. Now make it our equation 1, so therefore RA plus 4 kilonewton, this 4 kilonewton we substituted it from here, our RB is what 4 kilonewton, so RB will be changed to what 4 kilonewton, then equals what 8 kilonewton. Therefore our RA will now be equal to 8 minus 4. This our 4 here cross the equal sign and then comes to this place side of 8, and then change to a negative 4. So therefore our RA is going to be equals to what 4 kilonewton. Then if you are to work with RB, this is how it's done. I'll shift my diagram to the other side, and because I'll still work with it too. So for RB, we have what when taking moment at RB at this point here, so we'll have RB multiplied by the distance of 0, because we are taking the moment here, so the distance will be 0, so plus RA multiplied by 4, this is our RA, and then the distance of 1 2 3 4, so our RA is going to be RA multiplied by 4, then equal to, we have what 2, this 2, the distance from this 2 at point E to RB is 1, so we have what 2 multiplied by 1, then the distance at point D to RB is what 2 1 2, so we have what 4 times 2, then the distance from point C to RB is 3, so we have 1 2 3, so this makes it 2 times 3. Therefore if we will now bring down all the values we have, our RB is multiplied by 0 is nothing, so it's out. We have what RA times 4 is going to bring down, okay, we are going to bring down our RA times 4, then equals to our 2 times 1 is what 2, then 4 times 2 we have what 8, we have 2 times 3 we have what 6 here, then our RA times 4 is brought down again, then 2 plus 8 plus 6 is going to give us what, 16. You can either divide both sides by 4, or you can multiply both sides by 1/4. Whichever way you want to work with it is still okay. So like now I divided both sides by 4. So divide both sides by 4, we're going to have what, RA multiplied by 4 divided by what, 4. So when you divide it by 4, this 4 will cancel this 4, the same thing as multiplication pattern. Then we have what, 16 divided by what, 4, and therefore we have what, RA equals to what, 4 as our answer. Then using equation 1, from equation 1 we discover that from equation 1, RA plus RB is equals to 8 kilonewton. Therefore we have what, 4 plus RB equals what, 8. This 4 here is the RA here is 4, so we substituted it to make what, 4 here. Then plus RB is equals what, 8 kilonewton. Therefore RB will be equals to 8 minus what, 4. Then our RB, making it subject of formula, we have to move this our 4 to cross this equal sign, so it's going to change to minus. We are having 8 minus what, 4. So our final answer is going to give us what, 4 kilonewton as our RB. So let me bring down my diagram, because we'll use it for our shear force and bending moment what, calculation. Okay, now these are shear force and bending moment. These are shear force and what, bending moment, and we have to calculate them. So first of all, we are going to calculate the shear force before we go to the bending moment. The shear force is just normal addition and subtraction. So let's go. Now at RA, which is this point here, initially it's going to be 0 kilonewton. Then by the time a force is applied, which is this RA at reaction applied, a 4 kilonewton force was applied to it to boost it upward. Then at C, is this point here, we have what, 2 kilonewton. Therefore the shear force they are going to have on RA, which is this RA that is here, minus the force here pulling it downward. So we are going to have which is C, RA minus C, we are going to have 4 kilonewton minus 2. This 2 is this C here. So by the time you see 4 minus 2, we are going to have 2 kilonewton left. Then at point D, we have what, RA pulling it upward, which is this one here. Then minus point C, which is 2 kilonewton pulling it downward, and also 4 kilonewton pulling it downward. So we are going to have a total we are going to have RA minus C minus D. Now substituting their values, we are having RA, which is 4 kilonewton, minus C is 2 kilonewton, minus D, which is 4 kilonewton. Then we have 4 minus what, 6, because minus 2 and then minus 4 gives us what, minus 6. So plus 4 minus 6 is going to give us what, minus 2. At point E, here we have what, RA, which is this RA here, then minus C minus D minus E. So these are what we have here. So we are going to, by substituting it, RA is what, 4, then C is 2 kilonewton, then D is 4, and then E is what, 2 kilonewton. If you add your minus 2, minus 4, and minus 2, we are going to have total of minus 8, and then this our 4 here is brought down here. Then 4 minus 8, we are going to have what, minus 4 kilonewton. Then at RB we have what? At RB, RA minus C minus point C minus point D minus point E, then plus RB. So look at them here. We have RA minus point C, point D, point E, and then plus RB. By substituting, our RA is what? 4 kilonewton, our C is 2 kilonewton, our D is 4 kilonewton, our E is 2 kilonewton, our RB is what? 4 kilonewton. So this minus 2 minus 4 minus 2 again is going to give us what? 8 kilonewton. Then this 4 here plus this 4 here from the both reactions are going to add together to sum up what? 8 kilonewton. Then 8 minus 8 is going to, we are going to have what? 0 kilonewton. Then checking the shear force diagram. This is the shear force diagram, and this is how the shear force structure look like. Then let's work on it and see how it goes. Now for our reaction at A, we have 4 kilonewton. So at initial 0 kilonewton, which is here, then it was now boosted to what? 4 kilonewton here. And since it's not UDL, you are going to have a straight line. So the straight line making here also 4 kilonewton. Then we also have at point C, we also have 2 kilonewton pulling it, and so since it's put downward, we are going to have what? Pulling it downwards with 2 kilonewton. So at this point here, we are going to have a 2 kilonewton. That is what we have here at point C in our shear force calculation. We have at point C, we have what? 2 kilonewton. At our point C, we have what? 2 kilonewton. So our point D, we also have what? Negative 2. So let's see how we got that one also. Okay, so now this is what? 4 kilonewton, and since there is no UDL here, initially here was 2 kilonewton, and also there is a straight line. There will be a straight line. If it's UDL, there will be a straight line, it will be an incline. So our at D, we have a force of 4 kilonewton pulling it downward. So pulling it from here to here is 2 kilonewton, because I did my unit 2, I did it 2 units. So from here to here is 2 units, which is 2 kilonewton. Then from here to this other side is also 2 kilonewton. So putting it from here to here, 2 plus another 2 again makes it what? 4 kilonewton complete. So this place is going to become minus negative 2 kilonewton. Then 2 kilonewton here, then there will be a straight line. And after the straight line, we also have what? At initial point, which is first stage, here is also minus 2 kilonewton. Then the second stage here, we have 2 kilonewton pulling it downward from the E direction. The first pulling it downward, which is 2 kilonewton here, is M2, and once it pulled it down with extra 2 kilonewton from the initial minus 2 kilonewton, and it becomes what? Minus 4 kilonewton. Then you draw your straight line down here. Then from this point out, that is when our RB comes to work, and then pull it down towards 0 kilonewton, because our RB value is what, 4 kilonewton. Let's go for the bending moment. I have to take my diagram this way because I'm done with shear force. On the bend, I'm done with shear force. So now for the bending moment, we have what, at RA, taking moment at RA. Now we are going to have, now at this particular point, you are going to take the moments individually. Only if you are looking for reactions, that is when you can look take your bending moment specific for either your reaction A or your reaction B. But when calculating for bending moment at this particular stage, you work on the bending moment, you are going to work on each of the points individually. So at point A, at RA, we are going to have RA multiplied by distance of 0. So you're going to have 4 times 0 is equal 0 kilonewton. Then at point C, this point here, we are going to have what, RA multiplied by distance of 1 to point C is what, 1. So at point C, we have 2 kilonewton multiplied by distance of 0. So we have what, RA multiplied by 1 minus C times 0 distance. So this one is also out. C times 0 is out. So we have what, RA times 1. So RA is what, 4 kilonewton. We have what, 4 multiplied by 1 is equals 4 kilonewton. And at point D here, we have what, 4 kilonewton. 4 kilonewton, we have RA multiplied by the distance from RA to point D is 2, 1, 2. So we have what, RA times 2 minus the, at point C, we have what, 2 kilonewton. So the distance from 2 kilonewton to D is 1. So we have what, C times 1. Then at D, you have a distance of 0, which is D times 0. So we are going to have by substituting, our RA is what, 4 times 2 minus our C is 2 times 1, then minus our D is 4 times 0. So 4 times 0 is out, and we have what, 4 times 2 gives us what, 8 minus 2 times 1 is what, 2. Then 8 minus 2 will give us what, 6 kilonewton. So 6 kilonewton is what we have at our D. Then at point E, we have what, RA times 3. At point E here, we have what, RA times the distance 1, 2, 3. Then this is it, RA times 3. Then at point C, the distance from point C to E is 1, 2, is 2, this is 2 meters. Then we are going to have what, 2 multiplied by what, 2. Then at point D, the distance from point D to E is just 1 meter. So we are going to have 4 times what, 1. Then at point E, the distance is 0. So we are going to have 2 times 0. So therefore, by substituting, we are going to have what, RA is what, 4 times 3. Then our C is what, 2 times 2. Our D is what, 4 times 1. Our E is what, 2 times what, 0 distance. So our 2 times 0 is what, out. So therefore 4 times 3 is going to give us what, 12. 2 times 2 will give us 4, and then 4 times 1 will give us what, 4. Then you put your negative your signs on them. Then you put your signs on them. Minus 4, minus 4. Therefore, you are owing, that means you are owing Mr. A and Mr. B $4 dollars. By the time you add the total amount you are owing them, therefore the total amount is going to come out as 8 naira, $8. Then you have $12 to clear your debt. By the time you pay with your $12, you have what, $4 with you. Then at ROB, action at B, we have what, the distance from RA to ROB is 4, 1, 2, 3, 4. Then the distance from so it's going to be RA multiplied by 4. Then the distance from point C to ROB is 3, 1, 2, 3. So it's going to be 2 multiplied by 3. Then the distance from D to ROB is 2, 1, 2. So it's going to be 4 multiplied by what, 2. Then the distance from point E, the distance from point E to ROB is 1. So we are going to have what, 2 multiplied by 1. Then at ROB itself, the distance is just 0. So everything there automatically becomes what, 0. So if by substituting what we have in RA here, we are going to have 4 times 4. Then at C, which is minus C times 3, we are going to have minus 2 times 3. Then at D, which is minus D times 2, we are going to have what, our D is 4, we are going to have minus 4 times 2. Then our E is 2, we are going to have what, minus 2 times what, 1. Then plus our reaction at B is 4. This is plus 4 times 0 kilonewton. Then automatically our reaction at B is 0 is 0. So therefore we are going to have what, 4 times 4 gives us what, 8, minus 2 times 3 gives us minus 6, minus 4 times 2 gives us what, minus 8. Then minus 2 times 1 gives us what, minus 2. Then minus 6 minus 8 minus 2 give us total what, minus 16. Then 16 minus 16 will give us what, 0 kilonewton. And whenever you are solving, don't forget to add your kilonewton so your work won't be like mine. Let's go to the bending moment diagram. The bending moment diagram, our maximum bending moment is at this point, which is 6 kilonewton. At D, which gives us what, 6 kilonewton. At D, we got what, at D, at D we got what, 6 kilonewton. Then at E we got 4 kilonewton, and also at C we got what, at C we got what, 4 kilonewton. So therefore our maximum bending moment is going to be at D. Therefore our maximum bending moment is going to be at D. At ROB we have what, at ROB here we have what, 0 kilonewton, while at RA we have what, 0 kilonewton. If you like this video, you can share to your friends, they need it more. And if you haven't subscribed to my channel, please make sure you click the subscribe button and follow me up on my social media links, which is on the description below. So this is example 3 of this work. Don't don't be confused with these arrow signs I put down here. It means I'm trying to break things down for easier understanding. We have what clockwise direction equals anti